You may recall that the equivalent circuit for the basic op-amp is simply a voltage-controlled voltage source. Before we look at using operational amplifiers to implement other types of dependent sources, such as a voltage-controlled current source or a current-controlled voltage source, let's go back and take a little bit more detailed look at what we mean by a voltage-controlled voltage source. Here I've shown the standard inverting amplifier, except I've connected some sort of a load to the output terminal with some voltage V sub L across that load. V sub L is simply what we called V sub O in the previous circuit. Recall, once again, that since we have negative feedback, the voltage at the inverting input is a virtual ground. Thus, the current through R1 is VI over R1. All of that current has to go through R sub F since there cannot be any current into the inverting input. And thus the voltage across R sub F is V sub I times RF over R1. And due to the inverting nature of this, the output voltage V sub L is minus VI times RF over R1. In other words, that voltage V sub L is dependent on V sub I. As long as R1 and RF are fixed, it's simply some number times V sub I. Also note that the output voltage V sub L does not depend on what the load is. We never said anything about the nature of the load in determining what V sub L was. It's simply dependent on V sub I and the two resistors. The op-amp output will do what it must in order to make the voltage at the inverting input a virtual ground. Thus, we've got a voltage-controlled voltage source. Later, we'll talk about some limitations on this, which has to do with the non-ideal characteristics of op-amps. But for now, we'll just go with that. You could do a similar analysis putting a load on the output of a non-inverting amplifier, either the version we saw with a gain greater than 1 or the version with a gain less than 1, and you could do the same sort of thing and justify that it is indeed a voltage-controlled voltage source where the constant times V sub I is either greater than 1 or less than 1, or for that matter, you could even do it with a voltage follower where the factor in front of V sub I is simply 1. The voltage control voltage source is just the same voltage as input, but you have isolated the load from the driving circuit so that it would not affect the driving circuit. Okay, with that quick little review, let's move on to voltage controlled current sources, two of which are quite simple, one of which is a little bit more complicated.